Okay, now let's see how we handle these two questions here. So a stone is dropped from rest at the top of the cliff 125 meters high. How long does it take to reach the foot of the cliff, and at what speed does it take to strike the ground? So here we start by drawing a sketch for the whole thing. So we have our ground there. This is our ground. Now we are assuming that this is the top of the cliff. So the stone is being dropped. So when it's dropped, it's going to come like this until it hit that ground there. Now we start with from rest, meaning that our U from here is 0 meters per second. Why? Because it's from rest. Then we are telling us that this cliff is 125 meters. So that's the cliff. And also they are telling us that does it take to reach the foot of the cliff? So in simple terms, that here our acceleration is that it's going down. So the gravity is acting on it. So it's going to be D equaling to 9.8 meters per second squared. So now using our formula, we're gonna now, if you want now, how long so we need time. So now you start we are from here up to here. So how many can we use? We have the formula. It says that our S is equal to UT plus half AT squared. So we need this time. So we know that the initial is 0. So we have the acceleration, we have the distance, so we can use that. So our U here is 0, so our S, the distance is going to cover before it hits the ground. So when it hits the ground, we have covered the all of this distance. Now this is going to be 125 equaling to 0 times t, then plus a half. Now our acceleration is going to be the gravity because it's acting downwards. It's not opposing, that's why it's positive. 0.8, then this one is this squared. So from there, I have 125 equaling to half of this we get 4.9 t squared. So 90 squared will be this divided by that. So I get 25.51 after getting the square root there. So that our t will be 5.051 and is a second. So the time it will take this particle to hit the ground from here to here, it means that the time it will use to cover this distance, because it's from rest, that's why you have 0, and that will be the time. And with what speed will it hit? Will it strike the ground there? What are they asking for us to get? They are asking us to get the final velocity. So this final velocity is the initial 0. So they are asking us to get the V and when it hits that there. So here the velocity that RV is equal to U plus AT. So our final velocity we are looking for, this is 0 plus now acceleration, which is the gravitational force, then 5.051. And so the velocity we get this. And so here what we get is 49.4998 meters per second. So this is the velocity at which it's going to hit the ground. So this is the speed at which it's going to be raised and then it hits the ground. There. So in this, a particle is projected vertically upwards at the velocity of this. Find how long after projection the particle is at the height of 49 meters above the point of the projection. So here, we start with a simple sketch. Assuming we are projecting it from here, and then like that. So they're asking us, assuming this is the height of the projection, is projected vertically upwards at a velocity. So at what time will it hit at what, find how long after projection the particle is at the height of, so the height we are shooting, let me call this height to be 49 meters. Remember, it was projected, so our U, our initial velocity, is 34.3 meters per second. And so, that's all we have. We have the, and so what form are we going to use? Because so now the gravitation is acting against the gravity because it's going upwards. So, meaning our A is going to be negative D. Because it's going upwards, so it's in this direction, assuming it's here. So it's going upwards like that. So it's going to be now, our acceleration is going to be negative B. Negative B. So we have the acceleration, we have the distance, and we have the initial. Which formula suits that? So the formula we are going to use is when we have S equaling to UT plus half AT squared. Now the acceleration is going to be now the negative one. So our distance, we want this time. So for it to cover this distance, 49, it's going to be our U, 34.3. Then the time we are looking for, then minus, because this acceleration is going to be negative, half 9.8 T squared. So you see, if I reduce this by 2, I have 49 equaling 2343T, then minus 4.9T squared. Divide through by that. That's divided through by 4.9. We shall have T squared, this one, and we divide that negative there. I have negative 7T. When I take this side, I have now minus. I think that one is going to give us a 10. A 10. When I bring it to the other side, it will be 10 equaling 0. So from there, what do we see? Two numbers, I add again negative 7. I multiply, I get positive 10. That will be T minus 2 and T minus 5 equaling 0. So either our T is 5 or our T is 2 seconds. So, meaning for the first time at part A, our T, the first time is going to be the smallest, 2 seconds. Then part B, this one is going to be 5 seconds. And so that's how we handle that. Whenever I switch, the ideas are going to be very easy to apply these ones. So that's members we should wear.